Well, thank you, everyone. Definitely some amazing and interesting presentations today. Saw from a lot of different sides that is very different from my background. It's very interesting to kind of see the diversity of the presentations here today. Um, I think as I was kind of thinking globally about all of the presentations, I think what's kind of in common is that, a lot of us are trying to find methodologies for how we take large data sets or large amounts of information and begin to kind of coordinate them and communicate them into a series of either kind of BIM models or graphic sets, or through AI or through whatever means to really begin to communicate to our stakeholders. And I think that becomes a very kind of interesting challenge of coordination and how we do that. So I'm interested in how we begin to kind of think about this idea of like workspace 2.0 in the future, and how things like AI or AR will begin to reformat or rethink how we work in the future, and how it begins to change that format a little bit. As a general question.
I think you're absolutely right. I think there's an issue with us having too much information at some point. And I think this is something that generative AI is actually really well placed to help with. And that we can have it's very good at coming up with having a huge variety of insights and data points and being able to not only distill these into a summary that we can understand, which itself would be very useful, but also to go from there and also be an interactive summary, something that we can talk with and we can ask clarifying questions. And this is something that I know was talked about, for instance, having to repeat the same information over and over again to different stakeholders as they change. This is something that I think generative AI will be very useful out of being somebody that can keep track of all that information, where all those things happen. And so when a new person joins a project or takes over from somebody else, they can ask those questions directly to the people that, well, not directly to the people, but directly to the log of all the things that had happened before. So I think this is a really exciting way in terms of not even thinking about the capabilities of generating things, but just coordination, just removing a lot of those costs of being able to get people the right information right away and from different sources at whatever kind of skill level or understanding that you have.
Yeah, one aspect that I think is particularly interesting for the space that I work for one of the projects that I was working on, we were actually talking about using generative AI to write the requirements for a program, because that can often be a time-consuming process for any kind of project, regardless of size. And by having a pool of requirements and projects available on the internet, and then using AI to help sort of pull across projects, it helps with commonality, and generating common acceptance criteria as well, I think. So, yes, definitely something we were looking into.
Yeah,
I think an interesting point that Ryan. Oh, sorry. Go ahead, Jim. Sorry.
I was just about to say, I think too, the ability of these systems to be able to work with context and to kind of take on different, personas, essentially like agentic based understanding of different responsibilities, I think also solve some of the problems we've seen of like increasing complexity of projects, this idea of big central models that everyone has to figure out how to parse through. But the idea of systems that can essentially speak the language of all the different experts at play and be able to convey and translate all the right information to the right people so that they're able to work more effectively, and kind of smooth over the clashes that we see.
Yeah, I think Ryan, he was touching on a comment about, AI integration into engineering and, this kind of fear that people have with it. And it's really not that AI is going to replace workers, but it's those who are not sort of investing in it and learning it, and somehow integrating it into their workflows a little bit. Those sort of workers and engineers or architects, whatever we're talking about, become a bit more valuable. So I'm interested in this idea of those of us who are in sort of academia right now or involved in sort of teaching others is like, how do we sort of convince, or how do we begin to sort of reprogram how we teach and how we get sort of users to embrace these technologies and begin to embed them into their workflows a little bit? I think, on our side here academically, I teach young students in undergrad a lot, and you would expect them to somewhat be open-minded and be sort of malleable and accept this, but they are very sort of closed-minded. They actually have a more traditional kind of understanding of working, and they embrace that essentially more, maybe because it comes from them seeing their parents or whatever. So I'm interested to see how we start to kind of like change the conversation and adapt these kind of workflows now. This may be a question more for the team at Autodesk.
I think this is going to be changing too over the course of the next, several years, right? We've seen models that are very good at modalities of text and are very good at the space of images. And I think we're already seeing that pretty well adopted in academia, especially in the AEC space. I think just the proliferation of tools like Midjourney have totally transformed the way we think about imagery produced by architects, and kind of the ability to use this very flexibly in the kind of concept development space. But I think we're still at this point where models struggle in the kind of the core language of geometry, right? This semantic ability to link all these different things, and not just produce imagery, but also start to produce useful geometry, because a lot of our workflows ultimately still require explicit geometry definition. So I think this is where we're going to start seeing some kind of major moves in the space, and where we're going to start to see a real kind of transformation and uptick in how we start to integrate this into practice.
Mm-hmm. Yeah, because I think right now at FAU, we have a fully AI integrated studio, and it's not like a Midjourney or Stable Diffusion thing. It's, we work very similar to what you're doing with the Autodesk software. We're actually encoding data from Grasshopper models through a series of spaces through an encoder, and then it goes into like this Google Colab where it creates, anywhere between a matrices of maybe 250 to 1,500 different spaces that we then encode back into a JSON file, and then that goes back into Grasshopper, and then we decode that into a series of spaces. I think the challenge of that then, from a student's perspective, is that they have 1,500 spaces that they have to somehow evaluate on their own a little bit, and they have to go through and assess from criteria that they've developed of what has value in it. And I think that's sort of the challenge a little bit within all this AI sort of generated content, is like, how do we assess value, and how do we assess whether or not it's somehow going to be valuable, and not get lost within all of the amount of content that is sort of generating. So I think that's a unique perspective that we have to have, and we're trying to train towards right now.
Yeah, and I think
you were trying to touch on that a little bit in some of the generations that you were talking about.
Yeah, I think this goes to Adam's point, right? Is I don't think the tools we have right now are limiting in terms of we can make these incredibly complex models that kind of reduce the level of abstraction we're already creating about the real world, right? We obviously work through representations. We try to simplify things. The history of architecture is based on this. So we've gotten to this point where we can actually get closer and closer to reality. But like I said, is like people have fundamental limits in terms of the complexity they can create. We also have limits in terms of, how much time do we spend on programming these really complex generative models versus just designing in traditional ways. And I think, again, these are both opportunities for Gen AI to both help accelerate the process of developing complex models that get closer to an approximation of reality, but also more critically understanding and making decisions in that space. Because it really comes back down to decision making. We don't really want to be presented with tens of thousands of options, because that becomes overwhelming. Everything gets flattened out. We want systems that can start to highlight what's the difference, where are the kind of actionable points from a design perspective, and what are the impacts of making those decisions. And I think that's somewhere that again, Gen AI is really well suited for, because again, this ability to kind of work across modalities and to kind of use those modalities to also help explain in the different sorts of ways we need, whether that's language, whether that's imagery, and eventually whether that's geometry.
Hmm.
I was thinking, Tanya, if you see methods like this also helping to compose systems, when we now know that SysML 2.0, for example, can be text-based and graphic. Do you see techniques like that being used to compose systems, or options for systems, or do you think we have to have that more traditional way to model systems?
Sure.
In order to make them work?
Absolutely, yeah. So I think for me, one of the lessons that I've learned over time with the different projects that I've worked on, which have specifically used model-based systems engineering, is that engagement out of the immediate group of people using the model is very poor. So I think having a text-based way to access it in the way that SysML2 does can be really helpful in terms of engagement from that broader audience, to make sure that we're getting that all-round picture. and making sure that we're capturing their feedback as well on the systems that we're developing. So for me, I'm all for the more that we can increase accessibility to the models that we're creating and using, the better value we'll get out of them.
And Jim and Adam, do you have any thoughts about that, about this new open DAWing systems, and SysML2, and being able to express it graphically or text-based, and if there's an opportunity there to create a bridge between systems modeling and, let's say, BIM, with the techniques you're using, or other techniques?
Yeah, so it's not covered in this project. There are other teams specifically looking at that very thing within Autodesk Research. And again, I think that opportunity to think about especially AEC spaces and the kind of vertical building as being equally kind of systems based as the kind of infrastructural versions of these, whether we think about building systems themselves or the people occupying them. But again, I think that some of the interesting things we've started to see are again the ability of Gen AI models to kind of smooth the process of actually developing these things, to help people elicit the right requirements and kind of develop the right systems, and essentially smooth the path where you can have people. The intelligence of people is innate, but I think the ability of people to use some of the tools and become expert users of these tools has always been a bit of a challenge. So some of the process of actually accelerating the adoption of these tools, right? SysML has been around for a while. It's something we've talked about for a while, but it's still just it's a hard thing to kind of adapt to and to kind of get into. And again, the more ability of the software to understand this and kind of smooth that process, I think we'll start to really unlock, bigger things with that, because it'll increase adoption of these kind of underlying technologies.
Yes, absolutely. So one example we can give, I think Tanya, you're also familiar with that. So when we had to model business processes for a railway project we work on, when we model that in SysML, people look at the diagrams and they just glaze. They don't, business people, right? And then we have to remodel as a BPMN or create a nice and friendly diagram, completely different diagram, non-technical diagram, to convey that idea. So it's quite interesting that, as you say, generative AI could make that transition very easy. It would smooth the path for better communication.
And that's for that base. I mean, the most basic capability of these transformer models is this translation, right? This ability to speak multiple languages. And so I think that's even low-hanging fruit. And then once again, we can start to get to that point, we can start to see it be more directly involved, and we'll, I think, even see more kind of exciting capabilities emerge from that.
Yeah. Dustin, I just wonder if you want to invite the audience. I think Professor Robert H. is there, Alberto, who presented yesterday, is there, Sepeth. If they have any questions, thoughts, questions.
Yeah, I have a question. May I? Hi. Yeah, I'm here at the bar now. I'm the unique one, maybe. Yeah. Yeah, I love a lot of your presentations, this last part for sure. And I have a few questions for Adam or Jim. Also Dustin could also say something about this, I think. It's about the use of AI, in particular with training process, because it consumes a lot of energy. Yeah, so it's something that we cannot avoid. And usually we try to implement a custom model, takes ages. And I'm not sure if you have any, let's say, chance to maybe the people from Autodesk to implement an idea of framework who knows something simpler for the common user, because now the people who actually work are the ones who we are actually working with AI. We are really specific, kind of between commas, nerdies, just working all the time in the computer. But if we want to create let's say a better impact in the industry, maybe we must work with tools that are going to be easier in terms of how to train our own custom models, instead of just downloading things from the cloud, from the black box, all these things. So that's my question. Let's say, if there's any chance to do this simpler at a certain point.
I think that there is some inspiration that we can get. I mean, we don't have any of these models or anything like release or anything like this at Autodesk, but I think there is some inspiration you can get from the open source image generation community. People like Stability or something like this, which basically release their models and and then you can do these kind of fine tuning on top of it. And there's ways to do this in a very efficient way, where you can take 30 pictures of yourself and put yourself into one of these models, or you can take a particular, a particular style and add this in there with, one GPU, and it's not a big case, but from that you get kind of the backbone of the, how many hundreds of hours of training on gigantic machines that have been put out there. So I think there's certainly a precedent for finding ways to do this. We are ourselves, when we use experiments, we fine-tune GPT-2, and this we can do. This is very cheap. Or our bigger experiments, we can do this with llama herds, llama models, and we can also do this on a single modern GPU these days, and fine-tune these to our particular tasks. And so, I don't know I'm a researcher. I have no idea what the business cases for all these things are. But in my vision, what the thing would be for Autodesk to provide these kinds of foundation models for architecture that then other people could take and use for their own abilities. And I don't know how we make money off of that, but that's not my problem. That's above my pay scale. But this is where I could imagine seeing it going. Just the way that all these other generative AI, model makers are finding ways to also make money, but also, through whatever other requirements. So not everybody has to do this from scratch. It's kind of crazy for everybody to do this from scratch. But I think a lot of the architectural problems that we have to solve in the end are similar. And so if we can create models that speak that language, then we can fine tune them to our own particular cases.
I think for us, to go back to what we're doing in the studios and architecture right now with our students, is that we're able to kind of build a fairly simple visual grasshopper definition for students to work with. And there it has a series of kind of limited parameters that they work with, that they kind of input this or control this data set somewhat. So for them, the real energy is just developing the criteria. And then once they have the criteria, it'll just be then encoding that as a spatial criteria, and then taking that encoded data into the AI and allowing AI then to create 250 or so, however many spaces we want to generate with that. And then somehow, in terms of time, it takes maybe an hour to compute that, and then we take it back into Grasshopper and then decode that information into digital models, and that takes another hour and a half. So you have something within like maybe a 3 or 4 hour time range, but you're getting an output of 250 unique discrete options to evaluate. And so I think that I think the more complex the data set becomes, obviously the more energy and time it's going to take. So like the more parameters you're putting into that, it becomes more challenging. I think for us, it's building that up incrementally a little bit so that we understand conceptually how these things work, and then we understand, once we have something, then how do we begin to work with it and actually map that or create an architectural project from that through a set of conditions or through a site constraint, for example. So, I think that's how we're trying to kind of incrementally integrate and build it up, so that people kind of understand it. I think that's the hardest thing. It's like wrapping your head around, or we'll say releasing your control on it yourself. Because I think as architects, we certainly want to control and sculpt the space ourselves. So we have to somehow give that up and let this thing just sort of do its magic and do its work and then evaluate. And I think that's what's hard right now for us.
Yeah, absolutely. So, Dustin, I'm noting the time. So, shall we do a round of final comments, and then we can close this session?
Absolutely. I don't know if you want me to throw this curveball out or not, Abel, but this idea of that we were sort of talking about how AI begins to think about or integrate natural systems, I think is an interesting sort of question right now. One that maybe is a more for the Autodesk group of, I think you're looking at sort of very kind of fixed parameters, but when you start to throw in like agent-based systems or natural systems, it starts to throw like some challenges in there for you. So I'm not sure if you're looking at that or how you think about that, or if you have any comments about that.
Again, these are all areas of research that aren't necessarily covered in this particular project we presented, but I think again, all these things are kind of in play here. I think I'm most excited about this. Coming from the background of being an architect with computational design background, I think there's a badge of honor earned from kind of learning to like wrangle with these systems, and I think some of that is really enriching and really rewarding, but I think also too it creates a bit of exclusivity within our community where there's some very technically minded people that are able to do a lot of really great things, but still kind of struggle against these things. And I really am excited about the opportunity of this starting to make tools more kind of less of the badge of honor of just like kind of getting the tool to do what you want, and more of it being kind of effective partners and really starting to understand, not just get it to do what you want, but actually for it to be more intuitive, to actually understand what you want at a deeper level, and to start to really kind of be more of a collaborative partner. I think this idea of like human-machine collaboration is really exciting. And again, I think all these different approaches and all these different techniques are going to start to be wrapped up in some of these Gen AI approaches we're looking at.
Yeah, I think it's a great sort of comment. I think it's kind of trying to find the unexpected outcomes, or that kind of process of discovery, and I think that's what's exciting about it somewhat. And again, it's like you said, it's forming the collaborative. It's a new collaborator. So how do we sort of integrate this new collaborator?
Yeah, I would say I'm also in that same way, like excited about what happens with the next step of these, because I mean, there's been a lot of generative design where we work on things like geometry and we find nice ways to do conceptual design of certain things. But I think we're starting to reach a point where, in terms of finding the unexpected, we may be able to, be doing, this kind of conceptual design in a computational way. But what that's going to mean in terms of a first draft could go all the way up to, structural design and plumbing and electrical, and seeing how you can actually play around with how an entire building fits together. Because maybe these things will also be able to sort of be produced in a generative way. And so I think just opening up that amount of space for exploration, even if we're sort of the one steering it, and then you see all the things that kind of come from your initial decisions or come from these random interactions, sort of how much this can unfold is going to be increasing at an incredible rate. So we're not just unfolding what kind of interesting geometry can hold something up, but saying, oh, with this kind of interesting geometry and way that's starting the spaces, then oh, this actually does a lot for the amount of sunlight that reaches this room, which means that the amount of HVAC we need in this other part actually decreases quite a lot, and that makes the atrium can be bigger for this. And I think there's a lot of things that will follow on to this as these systems have become a lot more capable of handling entire systems, a lot more than what we've seen in the past with generative design, where we're really kind of have to work at a fairly limited level, not all the complexity that goes into reducing the construction schedule time based on some design decision we made early on. This is kind of beyond what we can do now, but as these systems become capable, we might be able to get estimates that far ahead of the process. And then, I think there's a lot of interesting things we could find.
Maybe add that, in the agentic space too, I think that it's also, we're at a point now where we can start to, we have a lot of really good tools that kind of explore the hard edges of the world. So like whether that's interacting with manufacturing technologies or working with validated simulations like Daylight that we know a lot about, but we always kind of skirt around the softer problems of the people and how people experience space. And, we can design the best spaces and optimize them, but if people, open the windows in the wrong way, it breaks these very complex systems. So I think the ability of these models to start to touch on that like softer part of design, the part that's harder to kind of grasp with at an empirical level, but kind of providing that approximation of what human experience is going to also start to really transform the way we design as well.
Yeah, I think that is something that another one, there's a lot of exciting things. I think just this ability to, I mean, didn't just touch on it a little bit, but being able to, we have all these like generative design spaces, and we create a huge number of these, and how we evaluate these. I think we've been limited before to very objective metrics. And now we're getting to a stage where we have these models that you can actually evaluate these subjectively, if that makes sense, where you can show somebody and say like, you can put a bunch of mock-ups and say, rank these based on coziness, and there's no way that any of us could write code for what cozy means, but we have machines that can do this now, like, and there's ways that we can then, get this kind of feedback automatically about what the subjective experience is. And that's also a whole new frontier of what we could do with these generative systems or with evaluating these systems that I think is a really exciting capability.
I'd just like to say one thing to Adam. I have never heard the word in all my time at the Bartlett School of Architecture. I have never heard the word cozy. Which I congratulate you on using that word. But okay, so I recognize that this is a research project, and research projects are constrained, limited. They achieve certain things. What happens next from an Autodesk research project, we don't know, as you alluded to. But what you are pursuing is essentially convenience. All I have to do, is make an example and add some extra criteria, and I get a result. Okay, so my high school physics teacher said, if in doubt, work it out from first principles. But essentially, these are very opaque systems. So it's very, you were very generous in talking us through the steps, and but of course you had to go quite quickly, so we couldn't really follow it in that detail. But that's really good. But these systems are really opaque. So if you don't know how to work it out from first principles, okay. That the high school physics teacher's approach was, I assume you can work it out from first principles, but if you can't, then, and if you're can I use an expression, 2-bit architect, and you've got a project to do, wheel it in, mate. Okay. But I think this opacity of, the assumptions you're making in there are, ghastly, really. And nobody's, I don't know, a more discerning client is going to go to an architect and say, I don't want what is produced over here. Thank you very much. You've got to make something different for me. The rectangularity of your, assumption of orthogonality, of tiles, sorry, guys, the whole thing about architecture is we don't have to have production replication. We can have uniqueness. So, but going back to my original point, it's convenience. Grasshopper is convenient. It, as in the earlier session, we had Matthew Austin saying, well, if you have a system which hides all the abstractions, makes something convenient, you never get below the surface. You can do something, and the students can produce something, but they are not. What I'm interested in is people who think more deeply and who challenge assumptions. And I think we're dividing the world into consumers who go for convenience and who don't need to learn how things work, and those who really do want to find out how things work and want to challenge the system and work things out from first principles. And you're in a very interesting position, as I was when I worked for Autodesk, in that we are thinking about it in great detail, and we're thinking about the assumptions, but we're wrapping that up in a product which encapsulates that knowledge so that other people don't have to. And that's quite an interesting dilemma to be in. And I don't know, if I may say this, at a political level, both in Europe and in Britain with the Brexit decision, and in America with the recent presidential election. I think there's one group of people who see the world in terms of very simplistic terms, and other people who see things in much deeper terms of like global warming, inequality, and that reflects, I think that's a reflection of this division between those people who want simple convenience and those people who are working to create that, but they're not educating the larger mass on the real issues and thinking more deeply about it. It's very much a consumer. We're creating a consumer situation rather than a deep situation. And that's, I think, quite worrying. You know, before with computational design, you had to write the program. You had to think more deeply. What am I doing here? Okay, how do I represent that as code? How do I see it executed? So computation was a way of the individual computational designer challenging himself to have a greater insight into the problem. If we create really convenient tools, we flip that relationship. We no longer have that. We spend our time writing a nice little grasshopper model, we throw it into some AI system, back comes all the solutions. We haven't worked out those solutions. We haven't, you know, one of my mentors described computation as augmenting human intelligence and human abilities. It's rather replacing it. Now, that in many cases, the solution, you know, for the people who can't work it out from first principles, the solutions might be better, you know, but we are missing an opportunity. You know, the move from hunter-gatherer to farmer led to a cognitive decline, because you no longer had to think about hunting. You just sort of sat there and let the plants grow and the cows get fat, you know. What cognitive decline are we going to observe here? But of course, you're okay. You're entertaining your brain working on these systems. But what about the wider population?
I will say from my own experience, which I am even less than a 2-bit architect. I'm not an architect at all. And this system is a limited thing, but I think you touched on some wider things that I'd rather talk about than the limitations of our current system. And that is like what these tools actually are going to do to us and what these tools actually cause us to do. And I will say, since my job is primarily the language that I speak in besides presentations is in code. And I think I've done probably more coding in the past 6 months than I have in the past 2 years, and I haven't really written a line of it. It's all has been working with AI models to vigorously explain exactly what I want to be done, have this coming out in code, examining this code, running this code, adjusting this. And I found, even though I'm losing something in that I do not have as firm a grasp on the syntax of Python, about memory allocation and C and things like this. I don't have these skills really anymore, but what I'm working on in my daily life is at just one level higher of abstraction. And it's allowing me to do a lot more. I'm much more capable of doing these things than I was before. And so in terms of augmenting people, I think it does depend how you use it. I can also just type in, I want to do this, and have the first code that comes out, and then copy paste it and have it be done. I think that we will see people that are using these designs poorly to create poor things. I think that's going to happen with any technology. But I think as it is now, it's a huge force multiplier for people who do know how to use it. In the same way that we're automating huge amount, we went from hunter gatherers to agriculture, and that, I think that was a net loss, I guess. But if we went, if we talk about the automation of muscle power with steam and electricity, this also maybe gave us a cognitive decline for a lot of people that were, skilled craftsmen that were doing these things. But then, it gave birth to another level of complexity in terms of what people can contemplate. I mean, there were no skilled craftsmen that were going to be able to figure out all the microchips and the, you know, that we're actually producing now to enable all these advances. So I think there's certainly something lost, but I think we're also becoming, you know, more capable. Just you know, I don't know. It's a little bit tricky because there is some spiritual value in doing all of these things at a low level, and there's maybe some you know, building that cathedral completely by hand and knowing every little intricacy is also like this is also incredible and soul nourishing,
yes,
you know, and maybe produces something better in the end. But versus,
no, I'm not arguing for sort of simple, you know, this kind of primitivism. What I completely buy into the idea that you are now operating at a higher level of abstraction. Okay. What I would like to see is many more people operating like you are operating, but not people operating as consumers. I want them to be informed at a higher level. And the problem is that although you are doing that, maybe if you industrialize the results of that, it wouldn't lead that the population of people who are operating at your level will stay static, but the consumer population who are not operating at level will grow. So I'm not in any way, of course, personally criticizing you, but I'm worried about that consequence. And what would happen if you took, you know, like the architectural students of Dustin over there, you know, if you took away these tools, could they design, you know, a building?
I'm going to say no.
Yeah.
You know, if we took away the BIM tools of today, could people design buildings?
Yeah.
You know, if people took away slide rules, could they have designed, you know, could they have done this? I mean, we have to have these tools. I guess my hope is that if we can make a, you know, it may be a little bit glib, but if we can, you know, create AI to do act as a 2-bit architect, then there's no more jobs for 2-bit architects. Everybody has to be a little more high performing to work, you know, or they're working with, you know, they can use their time to focus on those things that actually matter, rather than just, you know, pumping out multifamily residential, you know, housing complexes.
Yes, I also, Robert and Adam, I strongly believe that we have certain behaviors that will not go away. So it's a little bit like universal income. Is not because I believe that if you were to have universal income, we wouldn't always stop working. Some would, but some will keep themselves very busy because we simply cannot not do nothing.
Yeah, I mean, ultimately, the problem is it goes back to this question of like, as a practice, what do we prioritize in our education, right? I think like, historically, people were very good at drawing sections of buildings and detailing flashing, and I would say students of today probably don't do that as much. And is that as much of a problem? You know, we could say from a liability perspective is probably it's a lot of lawsuits still about water leakage, but you know, I think we're at a point where we really think intensely about tools, and a lot of the work is really informed by the tools that are being used for better or for worse. And again, I think this is just always the thing. We always need to kind of update our priorities as an industry and update our priorities in terms of what we convey and what we teach the new practitioners coming in for, you know, what does that mean? You know, if systems are able to start to understand and kind of solve the problems of drawing coordination, right? We have BIM, like, do we need to, how important is it to learn projection drawing? You know, I think it's still important to understand space abstractly, but, you know, again, we have systems that can coordinate drawings already. And again, I think we're just at this point where like something new is happening and we're not entirely sure how to grasp it, but we're going to start to see, you know, again, I think this is the evolution that just can't tell what's going to happen from an architectural education perspective, but something fundamentally is going to change because, again, the challenge of writing code or using Grasshopper is just going to drop. And the kind of technical barriers to actually use these really advanced tools and to kind of build in that space where you can, you know, use neuroplasticity and like suddenly you don't need to just, you know, understand the pattern of a snake in the wild and you can use it to turn into writing language and reading symbols on paper, right? Like we're at that point where we can potentially use our brain to do something different. It's up to people to actually kind of not be lazy and just kind of choose the lowest common denominator.
Yeah.
I think the tools ideally still need to have that level of not black box, not to be fully black box, that people still can like you're saying, Robert, like interrogate what they're building and really understand it. And I think do the things that are innate in design and kind of bringing ingenuity into design and kind of surprise into these spaces. And I think still finding ways to actually have those interactions, and those interactions might look different than a great for loop you've created or some recursive programming. But I think, again, some of those interesting things that happen in design are going to just manifest themselves in new ways that we're not entirely sure what the UX is going to be for that. But I think if those things disappear, we would see a pretty rapid rejection from the community of people who build things. Just because that's just, I think, inherently part of the culture of architecture and engineering.
Yes, I think, human curiosity will not just disappear and fade away. It's we biased to be curious, at least a percentage of us, all of us in different quantities. But I think still nowadays we can do an awful lot. We can 3D print buildings and so on. And some people still learn the craft of building buildings by hand. So when you think about human behavior as in a population, we are just too diverse for our behavior to be reduced so dramatically because of new technological advancements. So I suspect, if anything, we will create more diversity in behavior, and the curiosity will be there to explore that too in different ways, or to trigger an interest in a particular knowledge domain to drill down and learn everything about it.
I think, Abel, I was really interested that you had these people talking about SysML and organizing. I think that's really interesting that they were in the conference. And so taking a completely different tack, as I don't know whether the colleagues from North America know, but about 5 years ago, there was a terrible disaster in the UK where a residential building caught fire called Grenfell Tower, and like 80 people lost their lives. And there's just been a recent sort of public inquiry into what happened there. And essentially, the building was reclad with flammable cladding, compounded by the fact that the window frames were also flammable. So an internal fire that would normally be contained got into the cladding. Okay. And there's been a whole lot of finger pointing between the architects and the contractors and the material suppliers. So what the systems modeling and engineering modeling people were talking about from Dassault Systems and using SysML, I mean, that is another area which I think the construction industry, which has typically been highly fragmented, some people would say that's an advantage, it's not a monolithic, but looking at and reasoning about the construction, and not just the construction, but the decision-making process and the role of the different actors in that. I think that's something which is, really has an important role to play, and therefore potential from the software industry's perspective of, just model checking, just like, okay, of course, you're looking at design software, but not all buildings would be, you might build these rules in, like, there is no inflammable material or space pathway, but that's an area which is of real concern to ordinary people, because in the UK there are hundreds of blocks of apartment blocks which are
they are being upgraded exactly because of that
billions of pounds or dollars worth costs. So that's where architecture and construction, which has previously been a very expedient and politicized and commercialized activity, could benefit from much more systematic analysis.
And sorry.
So I don't know, at a future conference, Abel, I think, it's wonderful to get the guys from talking about defense systems and, but what we really
I
need
did.
is applied to regular
I had,
architecture construction.
sorry, it's just a comment on this one. I had 4 people from defense who said, "Oh, we would love to present in a conference," and then when they back to their office, they disappeared. They never respond a single email anymore.
Oh,
So
God.
obviously their line manager said no way. So and it seems to be the culture. It's like a British defense. So 3 people I met and
From the construction industry.
no, they design jets and
Oh yeah. Okay. Well, that's okay. That's
weapons,
fine.
yeah.
But I think we need to, if this conference is organized towards architects, it needs to have these technologies apply, or somebody doing research saying this is how it could be applied to practical and even to retrofit issues.
But on that point, Robert, and I have firsthand experience with that. It's very easy to have a very good system where you can tick all the boxes and have a very bad result.
Sure.
So when it becomes a box ticking exercise, and you don't really think about what you're doing and your responsibility as a professional, it's very easy to just glaze over things and not get the result you should be getting. You might get a result that seems to be satisfactory for the delivery for a target state product, but in the long run, later the defects will be there, and eventually you'll have disasters. So it is very easy. One thing that I find interesting about Adam's and Jim's presentation today is that they seem to be presenting a solution that is on the other spectrum of design exploration when you compare with things like Midjourney, and also I think there is quite a few tools for image to 3D environment generation. They, like Midjourney, generate very unique, very bespoke imagery. And the tool we've seen today, it's quite different from that. And it seems like now we have the other side of the dimension, if you see what I mean, to start to develop our intuition about design from very bespoke and unique to more generic and orthogonal pattern-based, running a different simulation and simulations and learnings and give you a result. So I think that's quite interesting, but there is something there I think that we need to explore and think about on how to enhance our accountability of what we do and our responsibility as designers. And I think AI can help with that as well. And as you know, some people at UCL are looking to AI algorithms compliance in respect to a number of different variables. I think Professor Treleaven is looking to that. So AI validation according to a criteria, and how to develop mechanisms so you can look at AI algorithms and understand if they are doing the right thing or not.
So I think, just going back to Adam, I think you made the point that you are now being able to operate at a higher level of abstraction with these tools. But simultaneously, you might be, if you're, what you presented had so many assumptions built in, it was so opaque. Okay, so you might be in this very incongruous position where, yes, at one level, you're operating at a higher level of abstraction, but within assumptions which you're not aware of. And that would be ironic, to say the least. But I would say that the whole, and I really take Abel's point as well, that you can take, all these systematic and modeling and systems engineering things enable you to tick the boxes, but you don't get a good result. Surely all these tools must be aimed at helping people work things out from first principles to augment their intellect. That is not to just be convenient and productive, but to give them deeper insights. And I think I would pin that on the wall of Autodesk research, You know, this is, you know, if we're really doing something for humanity to make, you know, the world a better place, then we have to improve the way we think, whatever the tools are, and improve our ability to question everything, including the tools, you know. And you know, not get something like the Grenfell Tower disaster over again. I mean,
Yes, yeah, that's it. That I would love to hear your response, Adam and Jim, in respect to that. And also just go back to that point that there is a degree of naivety, at least in systems engineering for rail that I've been dealing with in the last 5 years and engineering digital twins. There is a degree of naivety that is very dangerous. And also in the build environment, they sometimes don't account for things that they should be accounting, etc. But yeah, I would love to hear what you have to say.
I would say that I'll see exactly what I can say. So this project was done basically just by me and Jim a year ago. And if you're interested in architects having a better, fuller understanding of what the buildings are that they are creating, having an understanding of why they can do what they can with spaces and with things like even materials and fire protection, you're gonna like the next thing that we do.
okay, I look forward to that. Okay,
So
keep me posted.
I can't say a whole lot more, but this is an exploration about what we could do with generative AI and generative design, and the next steps of saying that this kind of thing can work. It might not be necessarily a generative design kind of thing, but figuring out how to make architects better understand what they're building, to bring in expertise from other areas while they're doing it. To do this with these more advanced AI systems, something that we're working hard to do, to try to make sure that we're not going for the click a button, make a building. That's not what we're interested in for generative AI. What we're interested in is, as you're making a building, having very deep understandings of the implications of the decisions that you're making, so that you can design better. And so there's going to be automation of work, but a lot more about it's going to be about insights about the activities that you're doing and the implications of what you're doing.
Well, I'm very encouraged to hear that.
Yeah. And Jim, can I ask, you know, like because we had a presentation from DeepMind last year, and there is always that question that keeps coming back, or that curious fact of, you know, DeepMind AlphaGo beating the world champion in Go, and having that moment that everybody thought that AlphaGo did the move that was very creative and was interesting, and the player learning from the AI. Did you ever come across? Did you have that feeling when you play with the tool that you develop in your research? Is there something that happened yet, or do you foresee this happening at some point?
Yeah, I mean, that's always on our side. That's always a kind of metric of, is this a useful tool? Like, can it surprise us, right? Like, I think tools that can't surprise us, and like, if a generative design system that explores thousands and thousands of things produces what you would have sketched out in the first place, that's not a good use of tools. And I think that's always something to keep in mind. You know, I think one of these things is hard, especially when presenting some of these design technologies through the lens of like an example project, is to dissociate what you see on the screen of design and the kind of methodology behind it, right? Like, there's no one project that's an exemplar of all the best practices. You kind of provide little windows into that. But yeah, I think again, the ability of these tools to both surprise us, not only what they produce, but also I think there's a surprise here in terms of it understanding, right? Again, I think we're used to this idea of like kind of playing the sliders in parametric models and like sampling things, but the ability to kind of ask it to do something like make a bigger park that has more sequestration, and for it to do that is in itself surprising. It might kind of be a little bit underwhelming in terms of what you see on the screen, but like I think that level of understanding is something that's just been very hard to do with conventional tools, and we're starting to see it become easier and easier, and kind of again reduce those barriers with which we can start to interrogate and challenge models to produce things that are interesting and surprising. So again, I'm very excited about that. I'd love for other people to kind of use this tool and to build their own design systems. I don't think you see that we really glossed over the idea, like the effort of actually creating interesting design happens up front of the system here. Like it's the parts of that go into the system that actually decide whether it's a interesting building to look at. Is it all orthogonal? I think is a question that's an architect's problem, not a design system problem. And so again, I think the opportunity here is like when more people start to play with these tools, we're going to start to kind of see some exciting things. And again, those will start to create challenges that hopefully, again, the tools can continue to react to and to grow in terms of what capabilities they produce. And I think, again, thinking about the community that we already have and how do we start to open these things up, like Adam was saying, models that people can build upon. Autodesk ultimately provides the tools. We can't support every edge case, but we have a great community of people who are very smart and very ingenious in terms of coming up with new ideas. So can we give them the kind of bedrock to actually start to create a very robust and exciting new design space with these new design tools?
Yeah, I am a very firm believer on human curiosity, and yeah, I think we need to play with the tools, and then new human behaviors will emerge from that, I believe.
Yeah, I think when I get a new tool, like I'm trying to break it. Right, we're trying to push it beyond its limitations, and we're trying to expose it in some way. And I think that's the case whether it's a digital tool or, for me, a machine. I mean, the machine has constraint and limitations, but I'm trying to push that tool beyond its expected conditions, so that maybe the outcome or the result is something unexpected, or there's some value in doing that a little bit. So I think that's what I'm sort of constantly after a little bit. To figure out where that limitation is, and to see, like, okay, once I've found it or meet it, now, like, what can I do within that scope? So I think that's really my workflow typically. And then that's why we push to integrate other tools into the design process. And I think in my process, it's sometimes integrating 7 or 8 tools simultaneously, and you're trying to work back and forth between them to find the optimal solution for the problem that you have.